Hi everyone. Exercise 8 was on prime factors, in which we solved the question to express the following numbers as product of prime factors. The method we utilized, it was the tree diagram method. Now we will be solving the same question using the division method, so both the methods get clear for you all. So taking a start, as you can see in here, the very first number is 30. Using the division method, what we do is we take a start with this 30, write it in here, draw a table-like structure, and take a start with the smallest prime number 2. 2, if 30 is divided by 2, we get 15. So it means it's divisible, therefore we take a start with 2. So 2 multiplied by 15 is equal to 30. Or we can say that 2 multiplied by 1 is equal to 2. The 1, since it's 3, 1 is lended to the 0, it becomes 10. 2 multiplied by 5 is equal to 10. So this way we get 15. Now the factor 15, we try again with 2, but we get a non-whole number, something around 7.5, which indicates that it's not completely divisible. So we try the next prime number, which is 3. 3 multiplied by 5 is equal to 15. It's completely divisible. Now the factor 5 that we have gotten, it is a prime number, so it cannot be divisible by any other number. Therefore 5 multiplied by itself. So 5 multiplied by 1 is equal to 5. We stop when we get 1. This way the factors that we received from this is 2 multiplied by 3 multiplied by 5. Writing these factors as product of prime factors, the syntax or the style is to write them in the ascending order, starting from the smallest prime factor to the largest, and in between them we use the multiplication sign. Now moving to 24, we start with 2. 2 divided by 24 divided by 2 is equal to 12. It is divisible. Then again, if we use 2, is 12 divisible by 2? So 2 multiplied by 6 is equal to 12. It is divisible. Is 6 divisible? 2 multiplied by 3 is equal to 6. Now 3 is a prime number, so it can be, the only factor is 1 in itself. So 3 multiplied by 1 is equal to 3. So the factors that we gathered, it's 2 multiplied by 2 multiplied by 2 multiplied by 3. Next we have 100. Again we start with the smallest prime, that is 2. 2 multiplied by 50 is equal to 100. 2 multiplied by 25 is equal to 50. Now 25 is not anymore divisible by 2 or by 3, because even if we divide it by 3 we get a non-whole number, something around 8.3, like this. So if we move to the third prime number, that is 5, so 5 multiplied by 5 is equal to 25, and then 5 multiplied by 1 is equal to 5. So the factors that we get is 2 multiplied by 2 multiplied by 5 multiplied by 5. Next number is 225. So 225 is an odd number, so it's not divisible by 2. So we try the next prime number, which is 3. So if we divide it by 3, 3 multiplied by 75 is equal to 225. Then 75, again 3 multiplied by 25 is equal to 75. 25 is not divisible by 3, so we move to the next prime number, which is 5. So 5 multiplied by 5 is equal to 25, and then 5 multiplied by 1 is equal to 5. So the factors that we get is 3 multiplied by 3 multiplied by 5 multiplied by 5. Again, in the ascending order we write them with multiplication sign between the factors. We have 360, as you can see in here. So 2 multiplied by 1 is equal to 2. In here we are having 3, so the 1 is being lended to 6. It becomes 16. 2 multiplied by 2 multiplied by 8 is equal to 16, and 2 multiplied by 0 is equal to 0. Or we can simply say 2 multiplied by 180 is equal to 360. So it completely divides 360. Then we check if 180 is divisible by 2. So 2 multiplied by 90 is equal to 180. 2 multiplied by 45 is equal to 90. Now this 45, it cannot be further divisible by 2, so we switch to the next prime number, which is 3. 3 multiplied by 15 is equal to 45. Then 3 multiplied by 5 is equal to 15. Then this 5, it cannot be divided by 3 completely, therefore we move to the next prime number, which is 5. So 5 multiplied by 1 is equal to 5. 504, again the same. We take a start with the smallest prime of 2. 2 multiplied by 252 is equal to 504. 2 multiplied by 126 is equal to 252. 2 multiplied by 63 is equal to 126. It is no longer divisible by 2, therefore we move to 3. 3 multiplied by 21 is equal to 63. 3 multiplied by 7 is equal to 21, and then 7 multiplied by 1 is equal to 7. Whenever we get 1 in here, we stop. So these are the factors, again written in ascending order with multiplication sign between them. These 4 numbers are also being done the same, solved in the same manner using the division method. We write the number, draw a table-like structure, and in here on the left hand side we put the number upon which we divide, upon which 650 is divided by. So starting with the smallest prime 2 multiplied by 325 is equal to 650. Then 3 is not able to divide 325 evenly, so we move to the next prime number, which is 5. So 5 multiplied by 65 is equal to 325. 5 multiplied by 13 is equal to 65. 13 being the prime number itself, it cannot be divisible by any other by any other number, so therefore 13 multiplied by 1 is equal to 13. 1125 is done in the same manner. It's not divisible by 2, so we switch to 3. 3 multiplied by 375 is equal to 1125. 3 multiplied by 125 is equal to 375. Then we switch to the next prime number because it's no longer divisible by 5. Divisible by 3. So 5 multiplied by 25 is equal to 125. Then 5 multiplied by 5 is equal to 25, and 5 multiplied by 1 is equal to 5. 756, again in the same manner. 2 multiplied by 378 is equal to 756. 2 multiplied by 189 is equal to 378. Then 189 no longer divisible completely by 2. We switch to the next prime number, which is 3. 3 multiplied by 63 is equal to 189. 3 multiplied by 21 is equal to 63. 3 multiplied by 7 is equal to 21, and 7 being the prime number, having only 2 factors, 1 in itself, so we use 7 multiplied by 1 is equal to 7. 9240, one of the biggest numbers. Again, we take a start with the smallest prime number 2. Multiplied by 4620 gives us 9240. Then 2 multiplied by 2310 gives us 4620. Then 2 multiplied by 1155 gives us 2310. 1155 not anymore divisible by 2, so we switch to the next prime number, which is 3. So 3 multiplied by 385 is equal to 1155. Then 385 not divisible by 3, we move or switch to the next prime number, which is 5. So 5 multiplied by 77 is equal to 385. then it is 77 is not divisible by 5. We switch to the next prime number, which is 7. 7 multiplied by 11 is equal to 77, and 11 being a prime number itself, um, we divide 11 by 11, that is 11 multiplied by 1 is equal to 11. And you can see that all the factors we have